Okay, let's unpack this. Welcome back to the deep dive, our mission today. A really quick, sharp look at the latest from Google Cloud Platform. We're aiming to find those practical updates, the stuff that helps you, if you're sort of beginner to intermediate level, get smarter, faster, and definitely more secure.
Yeah, absolutely. And looking through these updates, there's a really clear theme emerging. It's all about making things easier,
Mm.
you know, more automation, better security baked in, and honestly, huge cost savings, especially around Gen AI.
That's what jumps out. Automation, security, cost efficiency. It feels like they're trying to streamline the whole operational side.
That's exactly it. Reducing friction,
Hey,
taking away some of that repetitive work in managing security or costs so you can focus more on the interesting parts, the architecture, the actual application logic.
Right. And speaking of interesting parts, or maybe stressful parts, money. Let's talk about AI costs. That takes us straight into section 1. A smarter way to deploy AI, focusing on Vertex AI and making it, well, cheaper. So for anyone maybe not super familiar, Vertex AI is basically Google Cloud's main hub for machine learning, building models, deploying them, scaling them out. And the big news is something called Vertex AI context caching. The claim is pretty wild. It could cut the cost of running some AI apps by what, up to 90%?
It is a shocking number, yeah. And faster responses, too. It's not just a small adjustment. It really changes how you think about using large models.
How does it actually work, though? 90% sounds almost too good.
Well, think about it. Often, you have this big chunk of text, maybe a company policy doc, thousands of tokens long, or like a legal template.
Hmm.
And with many setups, you'd send that same block of text with every single user query. The model had to read and process that expensive context again and again and again.
Right, paying for the same computation repeatedly.
Exactly. Caching just stops that. It saves the result of processing that initial input, those pre-computed tokens. So the next time a query comes in needing that same context, it reuses the saved result instead of recomputing it.
Okay, so let's say I'm building an internal chatbot. It needs our 10,000 token company policy guide for every conversation. With caching, I pay for processing that guide just once, essentially.
Pretty much, yeah. For that cache context. You save the cost, obviously, but you also get faster answers because the model isn't rereading the guide. It's just processing the new part, the user's actual question.
And there are two types, implicit and explicit.
Right. Implicit is the default. It works automatically in the background, kind of aiming for general cost savings where it can. Explicit caching gives you more control. You tell it exactly what to cache using the API. That's really useful when you need predictable performance and guaranteed savings, maybe for a really high-traffic application.
Okay, that level of cost saving really does change the game for designing AI applications. But building these things brings new problems, like managing the prompts themselves.
Oh, absolutely. We've all been there, right?
Mm.
Trying to track down which version of a prompt actually worked 3 months ago. Was it in that notebook? Or maybe that config file? It gets messy fast across a team.
So prompt management in the Vertex SDK hitting general availability, GA, is meant to fix that. Remind us, the Vertex SDK is the code library for interacting with GCP's AI stuff.
Yeah, it's the tool you use to control Vertex AI programmatically.
Yeah.
And this GA feature, prompt management, it basically lets you treat prompts like code. You could version them, manage them centrally, track changes. It's like applying software development discipline to your prompts.
Ah, so everyone on the team pulls from the same controlled source, makes collaboration way easier.
Exactly. And it connects nicely with the visual tools in Vertex AI Studio too, so you can work either way, visually or programmatically.
Nice. So that helps with text. But what about generating video? We saw updates on VO 3.1, that advanced video model. The takeaway seemed to be about getting more structured with prompts.
Right, moving beyond just throwing words at it and hoping for the best, the prompt and pray method, as they called it. If you want consistent, predictable video output, the advice is to use a 5-part structure for your prompt. Think about cinematography, the subject, the action, the context, and the overall style and ambiance.
So it's about engineering the prompt to get a more predictable, professional result. Less luck, more design.
Exactly. And that engineering mindset carries over into training big models too. Vertex AI Training got updates focused on making the whole process more resilient and efficient. They mentioned tools like Cluster Director and Dynamic Workload Scheduler. Basically, it means your big, expensive training jobs are less likely to just fail halfway through because of some temporary glitch.
Self-healing infrastructure, essentially, saves a ton of time and compute cost if a node blips out temporarily.
Huge savings, yeah. It lowers the barrier for tackling really large-scale training.
Okay, but making AI more powerful and easier to train, that
hmm
kind of leads us down a path where AI gets more autonomous, right?
Yeah,
And that brings up new security questions, agentic AI.
precisely. Agentic AI, where you have AI agents doing complex tasks for you, maybe booking travel, handling finances, that sort of thing. It's powerful, but it opens up brand new ways for things to be abused, new fraud vectors that old security models just weren't designed for.
So Google's proposing this framework for agentic trust using Recap TCHA. How does that work?
It's built around four core ideas, really focusing on identity and behavior. First, agent and user identity, knowing who or what is actually running the agent. Is it legit? Second, continuously analyzing the agent's behavior, looking for weird patterns, signs of misuse.
Okay, identity and behavior. What else?
Third is mitigation, using challenges that are hard for bots but easy for humans, like verifying through a mobile device, things that resist simple automation. And fourth is enablement, making sure legitimate agent activities like secure e-commerce can actually happen without being blocked by rules that are too strict. It's about securing that autonomous loop.
Securing the loop. That leads us perfectly into section 2, locking down your applications and infrastructure. Let's start with something basic but crucial, configuration management.
Right. The age-old problem.
Yeah, the big recommendation is always stop hard-coding configuration details, especially sensitive ones, directly in your code. That's where Parameter Manager comes in. It's Google Cloud service for managing application configurations centrally and securely.
And it's important to clarify what it manages. Parameter Manager is primarily for non-confidential configuration. Think environment settings like, is this the dev or prod database endpoint URL? Or maybe a feature flag setting, not passwords.
Okay, so non-sensitive stuff. Where do the actual secrets go then? API keys? Database passwords?
That's still absolutely the job of Secret Manager, Google Cloud's dedicated service for storing confidential data. The really neat part is how they work together. Parameter Manager can securely reference secrets stored in Secret Manager.
Ah, so the config file might say, use the database password stored in this secret manager location, but the password itself isn't in the config file.
Exactly. It keeps that separation and prevents that classic mistake where someone accidentally checks in a config file that has both the database path and the password right next to it.
Keeps things isolated. Smart. Okay, so config is managed. What about protecting the network edge? Google Cloud Armor, that's GCP's web application firewall and DDoS protection service.
Yep. Your front door security?
There were a couple of updates aimed at making life easier for folks managing really big, complex organizations. First one, hierarchical security policies.
This is a big deal for central security teams. It lets them set baseline security rules at the organization level. And those rules automatically apply down through all the folders and projects underneath. It means you don't have to chase individual teams to make sure they've applied the minimum required protections. It just happens.
Central control enforced downwards. Makes sense. And the second one, organization-scoped address groups.
Scalability and efficiency, basically. Imagine you have a huge list of IP addresses you need to block, or maybe a list of partner IPs you need to allow. Instead of copying that list into dozens of different security policies, you define it once as an organization-scoped address group. Then, you just reference that group in all your policies.
Update it in one place, and it applies everywhere.
Exactly. Saves it a ton of time and reduces the chance of errors when managing large IP lists.
Okay, network secured. But GenAI brings its own security headaches, right? Like prompt injection. That's where Model Armor fits in.
Yes. Model Armor is specifically designed to protect the GenAI applications themselves. It's model agnostic, meaning it works across different types of models. Your standard WA, like Cloud Armor, is great at stopping things like SQL injection. But it doesn't really understand the nuances of someone trying to trick a language model with a cleverly crafted prompt.
So Model Armor looks for those specific AI attacks, jailbreaks, prompt injections, that kind of thing.
Right. It integrates with Security Command Center, GCP's central security monitoring tool. And it uses a mix of techniques watching behavior, looking for known malicious patterns specific to LLMs, checking signatures to detect things like attempts to extract sensitive data, PII, malicious URLs hidden in prompts or responses, harmful content, even scanning uploaded documents for threats.
It's security tailored for the weirdness of conversational AI.
Pretty much. It's a necessary layer for these new kinds of applications.
Okay, cool. Let's shift gears into section 3, boosting productivity for data, compute, and developers. Big stuff here for data folks. BigQuery Studio, the web interface for BigQuery, GCP's serverless data warehouse got a redesign. What's the goal there?
Pure productivity.
Hmm.
They simplify the Explorer view, making it easier just to find your datasets, tables, and other resources. Less clicking around.
But the bigger win seems to be this new reference pane.
Oh, yeah. If you spend your day writing SQL, this is fantastic.
Yeah.
Think about when you're building a complex query, joining multiple tables, you're constantly flipping tabs, right?
Yeah.
Checking column names, data types, looking at table descriptions.
All the time. It breaks your flow.
Exactly. The reference pane shows all that contextual information, the schema, the docs, right there next to your SQL editor. It updates automatically as you type. No more tab switching. Just keeps you focused.
That sounds genuinely useful. We also saw Dataproc 2.3 on Compute Engine hit GA. Dataproc is the managed service for running big beta jobs like Spark and Hadoop. The highlight was a new secure image.
Yeah, a lightweight, highly secure image that achieves FedRAMP high compliance. Now, even if you're not working with government data, FedRAMP high compliance is a good sign. It means the underlying system is seriously locked down by default. Less attack surface for everyone, which is always good.
Better default security posture. Got it. And sticking with data, Dataplex, which is Google's data governance platform, now supports column-level lineage.
This is really important, especially as AI gets more complex. It's starting with BigQuery data. Lineage usually tracks data at the level this table came from that table. Column-level lineage goes deeper. It lets you trace the journey of a single data column through all your transformations and pipelines.
Why does tracing one column matter so much?
Trust and context, especially for AI. Imagine you're feeding financial data or health data into a model. You need to be absolutely sure where that specific piece of data came from, how it was changed, and that it's being used correctly. Column-level lineage gives you that granular proof. It's key for building responsible, verifiable AI systems.
Visibility builds trust. Makes sense.
Yeah.
Now, what about getting data into BigQuery from other places, like traditional databases?
Right, a common scenario is needing to analyze data locked up in, say, an Oracle database. You can now use DataStream, which is GCP's service for continuous data replication, to pull data from Oracle directly into BigQuery in near real time.
Okay, so data flows from Oracle to BigQuery via DataStream. What can you do with it then?
That's where it gets interesting. Once the Oracle data is in BigQuery, you can hit it with all the modern tools. Use Gemini models for natural language querying and just ask questions in English. Get AI assistants writing complex SQL. Run advanced machine learning models directly on the data using BigQuery ML. It bridges the old transactional world with new AI analytics.
Cool, but running all that AI and ML needs power. We saw the new G4 VMs are generally available now.
Yep, serious muscle. These are powered by the latest NVIDIA GPUs, the RTX PRO 6000 Blackwell server editions. The claim is up to 9 times the throughput compared to the older G2 instances for really demanding work. Think complex AI inference, high-fidelity simulations like robotics. If your workload is bottlenecked by GPU power, these are a significant upgrade.
Faster results for compute-heavy tasks. Got it. Okay, finally, let's touch on developer productivity, specifically coding assistance.
Yeah, AI helping us write code. It's moving fast.
Jules, that experimental coding agent that works with GitHub, is now available inside the Gemini CLI. That's Google's command line tool for developers.
Right. You can access Jules directly from your terminal using a simple Jules command. The use cases are pretty practical.
Yeah.
Ask it to find and fix security vulnerabilities in your code, help debug tricky issues, or even generate documentation. It's about integrating AI help directly into the developer workflow.
And support for more languages, too. The Google GenAI SDK now supports .NET.
Yes, that's a big one for enterprise developers, using C# and the .NET framework. They can now use the same unified SDK to work with Gemini models, whether they're using the ones from Google AI directly or the enterprise-grade versions on Vertex AI. One library to access the models.
Makes it easier for a huge developer community to start using these AI capabilities.
Definitely. And Google's own developer teams have been using these tools. Gemini CLI, Gemini Code Assist, Jules internally. They actually published 5 best practices based on that experience. The takeaway seems to be, these tools are incredibly powerful, almost becoming essential. But you need good practices around how you prompt them, and critically, how you verify the code they generate.
Can't just blindly trust the AI yet. Makes sense. Okay, let's wrap this up. That was a lot of ground covered. Key takeaways for me. Vertex AI caching for potentially massive cost savings, the importance of using Parameter Manager with Secret Manager for secure configurations, and the productivity boosts coming to BigQuery Studio.
Yeah, those are definitely highlights.
So what does this all mean? Taking a step back, what's the bigger picture for the practitioner?
I think it means the platform itself is getting smarter about operations. Google Cloud is clearly automating a lot of the background tasks. Think about cost management with caching, security enforcement with those hierarchical policies and Cloud Armor, data governance with Dataplex Lineage. The platform is handling more of the how, making deployment and management more intuitive, more controlled.
So our focus shifts.
It has to.
Yeah.
And here's the provocative thought to leave you with. All these sources point to a future where AI collaborators like Jules, like Gemini, integrated everywhere, are doing more and more of the heavy lifting. They're finding the security flaws, fixing the bugs, maybe even deploying the infrastructure based on high-level goals. So if the AI is handling the writing, deploying, and securing, what skills become the most valuable for you? It probably shifts away from pure implementation details towards strategic direction, asking the right questions, critically verifying the AI's output, and really understanding the core business problem you're trying to solve. Guiding the AI, not just coding alongside it.
From implementer to strategic guide. Definitely something to think about as these tools keep getting better. A great thought to end on. Thanks for taking this deep dive with us today. We'll catch you next time.